Hi, Craig Hartman with VFDs.com. Today we're going to talk about how to troubleshoot a drive. Now let me emphasize that we're going to talk about some fairly simple things. Some of the best troubleshooters in the world occasionally get stumped when they're trying to troubleshoot a variable frequency drive. So let's just look at some of the main things. Right here is a variable frequency drive. This is a 480 volt drive capable of running about a 350 horsepower motor. So the first thing I would look at is I would look at the back plate. Virtually all back plates are white, and if you see smoke, soot, black smudges on the back plate, that indicates that something's blown up. So if you see black smudges around anything, then that's probably a failed component. So the first thing to do is take a look and see if you can find that. It only takes a few seconds. Next, let's take a look at how this drive is wired. So here we have R, S, and T. On most drives, R, S, and T come from the power input to the drive. Then you have N and P, that stands for negative and positive for the DC bus. In most cases, these aren't going to be wired to anything. Then you have U, V, W, which are the three phases that go to the motor from the output of the drive to the induction motor. So you might want to measure the voltage between R and S, then the voltage between R and T, and the voltage between S and T. All these things should have approximately the rated voltage of the drive, and they should be pretty well balanced within a few volts. So obviously, if you don't have voltage, you can't run the drive, and one of the most common reasons why people can't run a drive is there's simply no power there. So check this voltage. There's a circuit breaker right here. Maybe that circuit breaker is off. Now, if you have voltage, everything looks good, then we're going to assume that this drive is operational for the time being. Now let's take a look at the keypad and see what we can do from there. So we have here a demo drive. It's a demo drive with a detachable keypad. So we're programming a Mitsubishi drive with their high performance parameter unit. All right, now let's take a look at one troubleshooting scenario. I'm going to go to my keypad. I'm telling the drive to run, but it's not running. So let's push function, and then we go down here to troubleshooting. Not all drives have this, but on the ones that do, this can be a very effective troubleshooting tool. When we press read, it tells us what is the problem, and the top one says the motor's not running. Exactly what my problem is. When I push read, it says the motor is not running because MRS is on. Well, MRS stands for emergency stop on this particular drive, so it's pretty clear why it's not running, because the emergency stop signal is on, and this happens more than you would think. Now the next thing to do is to make sure that your basic parameters are correct. The first thing that you need to set is the volts per hertz. That means set the voltage for the motor nameplate and the frequency for the motor nameplate. So let's do parameter set, parameter 3 in this drive, and it is the volts per frequency, or volts per hertz, base frequency. That's 60 hertz, which is good for the United States, may not be good for Europe. The next thing we will check is parameter 19, which is the base frequency voltage, and that is not correct. So in this case, our motor is 230, so I type 2, 3, 0, and right, and now I have the correct voltage in. So make sure that the drive voltage matches the motor voltage and that the drive frequency matches the motor frequency. The next thing you want to do is check the motor full rated current. So in this case, this is the drive current in which it protects the motor according to what the motor full load amps is. So you simply put the full load amps in here, make sure that the full load amps matches the motor full load amps on the motor nameplate. The next thing we're going to want to do is we're going to want to check the maximum frequency. If the maximum frequency is too low, then obviously the drive's not going to run. So make sure your maximum frequency is where you want. The next one is your minimum frequency. Make sure the minimum frequency is where you would like to have that. You also need to make sure that you set your acceleration time and your deceleration time appropriately. So make sure that the acceleration time is not too short. If it's too short, you're probably going to trip on overcurrent because you're trying to accelerate too fast, which takes too much torque and therefore too much current. And on the deceleration time, make sure that your deceleration time is not too short. If it's too short, then you're going to try to slow down that motor faster than it is able to do. It's going to try to pump current back into the drive, and the drive's going to trip on overvoltage. So now we've taken a look at the software. Maybe things still aren't working. Let's go back and take another look at the hardware. The next thing to do is start taking some measurements. The first thing you should do is disconnect the motor. So right here we have U, V, and W. Physically disconnect those motor leads. Then you need to test the motor. Measure the motor out, make sure that it's not shorted, make sure that the motor is functional, and at least making sure that it doesn't have a short circuit. You are also going to measure the cables in going from the drive to the motor, and of course all that will be one measurement. If that looks good, let's try running the drive again. The drive does not need a motor in order to operate. So you can run the drive up and down. If the drive runs up and down successfully without the motor leads on, then we probably have a programming problem, though it's possible it could be something else. Now, if we have an overcurrent, that could be due to the fact that there's too much torque on the motor. If there's too much torque on the motor may not spin at all because we simply don't have enough current in the drive in order to overcome that torque. Maybe it runs, but after a while it trips. That could be that we're simply running that motor in overload, and after a period of time, that trips. In that case, of course, you simply have too much load. Now, if you get over voltage, that's an indication that the power is trying to go backwards from the load to the drive. Variable frequency drives are meant to take power from the supply and put that power into the motor. If for some reason the power is trying to come from the motor back to your supply, then it's going to go into the DC bus right there. That DC bus is going to continue to increase in voltage until the drive trips. So if you have an over voltage trip, that means the motor is trying to push power back into your power supply. That could be due to the fact that you're trying to slow it down quickly. That's the most common reason for this. Or it could be that you have something like a downhill conveyor in which you're trying to hold that motor back and that motor's trying to go faster than you're driving it. An overvoltage is generally an indication that you're trying to push power back. Now, if you get an overvoltage at night, it could be that the voltage on your power supply is going up. So check your voltage there, and one good way to prevent trips at night, if that's when they're occurring, is to put in some line reactors. Line reactors prevent that from occurring in many cases, and will also protect you from surges and spikes. So that's some basic tips on VFD troubleshooting. If you need more help, you may need a troubleshooting professional. Make sure and check out our YouTube channel for more educational videos, or check out VFDs.com for our wide selection of VFDs and VFDs accessories.